Hey guys, going to run through question 3.4 from tutorial 3 on rock mass, behaviour, discontinuity, strength. Question 3.4 is quite similar to 3.3 in that we're given data and we're asked to graph it, then analyse that to come up with a few things. So, we're given our JRC, JCS, length of joint, blah blah blah. Then they give us some normal stresses, 800 to 1600, and asked us to come up with the shear stress using the Barton equation. So, to do that, let's go to my answer. So these are the normal stresses, and we want to find the shear stresses for those normal stresses. First of all, we need to convert our JCS and JCR to the 5 metre ones. We're given the 100 millimetre specifications, so we use the conversion for joint roughness coefficient. Here's the formula, plug it in, you get that. Same for JCS, plug it in, you get that. Now that you've got JCS and JCR, you're going to put it into the Barton equation, which is that. And you know what your new JCS and JRC is. Do that for all the shear stress, normal stresses. So from like 800, 900, 1000, 1100, 1200, blah, blah, blah. You get all those. Then you need to plot it. So I've done it on Excel. Got my normal stress, shear stress. I've plotted it in. I had all the points, but in the question they ask us just to use 1300 to 1600 to estimate the Coulomb parameters. So I've put those 4 points in. I've inserted a trend line, a linear one, so r squared equals 1, so it's a perfect fit. And then I've extended the trend line all the way down here. So this looks like the Coulomb parameters. So the slope of the curve, that gives us our friction angle, and the intercept down here gives us our cohesion coefficient. So, according to Excel, the equation of that trend line is y equals 0.71x plus 81. So, we find our friction angle just by doing inverse tan of the slope. So inverse tan 0.71, 35.4 degrees. More or less the same as the answer in the question. They get 35.8 degrees, so I'm happy with that. To find cohesion, we want to find the intercept. So if you've got y equals mx plus b, you get the y-intercept when x equals 0. So the y-intercept is 81 from the trend line. So I would say the cohesion coefficient should be 81 kilopascals. However, the answer gets 60 something, so I'm not really sure what to do there. Hussein didn't really explain much in his answer. He just said, here's the answer. I didn't really go over shit. So anyway, that's the general method for most of these questions. Find the points with the Barton equation, do conversions for JCS, JRC, plot it out, and then either use simultaneous equations to get your cohesion constant, coefficient and friction angle, or read it straight off the graph. Hope that helped.